All right, here we go. Unit 3 review. Just make sure we're ready for the test. Everything's good to go. We're talking about absolute value and piecewise functions. Let's break it down. We start with these compound inequality. All that means is you have two inequalities here. So inequalities is greater than or less than is what inequality means. You've got two of them going on. In this case, I can look at it. This is an or situation. It's x is less than or equal to -4, or x is greater than 0. So remember, open dot is non-inclusive, solid dot is inclusive. You need the bar underneath so that it is equal to. If for some reason you had a graph and when I was shading it, it looked something more like this from here to here shaded, this would be an and. It's in between these, so you have and or. I always think of this as less than. And it's kind of weak. And this is an or means great or than. So when you think about great or than and you think about less than, awesome. So that was helping us solve absolute value inequalities. All this is an inequality with an absolute value sign. So the first thing you do is simplify it. Get all the way down just to the absolute value. So remember, divide both sides by 2 to get this thing rolling. And you've got this absolute value of 4 minus 3x is greater than or equal to 6. So what happens here? I can't do any more to the absolute value. So when you're ready to solve for the absolute value, this is where you get 2. You rewrite the thing, so 4 minus 3x. It's great or than, so it's great or than, so I know it's going to be this. Or what happens? I rewrite the same equation, 4 minus 3x, the absolute value, but I flip the sign. Why do I flip that sign? Because you're making this negative. So you're going to have two answers, this or this. So when you solve these, you're going to end up with something like x is greater than this, or it's less than that. And then what we're going to do is once we solve it, you'll get something like this. We'll put it on the number line, graph it, and we're good to go. Do we need to finish that? Yeah, let's finish it. All right, so if I subtract 4, I'm going to do it quick. Subtract 4 from both sides. I'm going to get 2. Divide that. Ooh, remember when you divide by a negative, what happens? It flips the sign. So this is actually less than or equal to -2/3. Or what's happening over here? Subtract your 4, so you get -3x is less than or equal to -10. What happens here when I divide by that -3? It flips the inequality, so make sure you flip that inequality. 10/3. So 10/3 is roughly, well, it's not roughly, it is 3.333 repeating, and 2/3 is -0.666 repeating. So if I do everything less than that, so here is -1, 1, 2, 3, 4. This is not really drawn to scale very well. Here's 3. So everything greater than 3.333, let me change colors here, will be everything and it's equal to this way, or everything less than -0.6 is everything this way. So shade that right on there, and you're good to go. That's section 3.1 if you're interested. Moving on, so we're now talking about just inequalities, graphing inequalities. So here's a linear inequality. Why is linear? Well, it starts at 1, 2, 3, 4, 5. And it's a slope of -1, down, it's down 1 over 1, down 1 over 1, down 1 over 1. And then you got to think about, is this a solid or dotted line? Well, this one's got to be what? It's got to be a dotted line because it's not equal to. So it's a dotted line, so if I do a dotted line through there, and then I'm going to shade which way? Less than means shade below. So everything below here is that. So that's just a linear inequality. Can I do absolute values? Well, yeah, this is the absolute value part of it. This is not an inequality. This is an equal sign. So this is just an absolute value function. Remember how do you graph those? Well, you're looking for the parts. You're looking for this vertical shift. It goes up 5, right 3. So that takes it over 1, 2, 3, up 1, 2, 3, 4, 5. And it's negative. So what's the negative do? That flips it upside down. And then the A is like the slope of it. So it goes down, rise over run 3 and 4. So it rises down 1, 2, 3 over 1, 2, 3, 4. And same thing in the other direction. 1, 2, 3, 4. Because they're symmetric. 1, 2, 3, 4. Once I have these, it's just graphing that. So I just connect the dots. It looks something like this. So you got to know what all the parts mean. The negative front flips it. The A is the slope of these. The shift right or left, shift up or down. Awesome. What if I give you the equation, though? Can you write it? Well, now it's not inequality because it's shaded. How is it shaded? It's greater than. Is this a dotted line or solid line? It's solid, so it's got to be equal to. So now in this case, I'm going to actually shade it. And then how did this shift? It shifted over what? It shifted 3 to the left. So I'm looking for 3 left. And it shifted up 1. So I need to make sure I have that all in there. So it's 1 up. So how do I do that? Well, I say x is to shift it left. It's opposite of what you would think. It's that plus sign. Up 1, it is what you think. It's just plus 1. Now, I know I need negative. What's the a in this? Well, we're lucky. It goes down 1 over 1, down 1 over 1, down. So it is negative 1. Or I can just put a negative because it is upside down there. Excellent. All right, let's take a look at piecewise functions now. So we covered absolute values, absolute value inequalities. Piecewise function, remember, is just a function made up of different pieces. So this is one graph, one picture, but it has 3 parts. It has this top function, this middle function, and this bottom function. So it happens over different domains or when x is different values. So it's an absolute value function every time x is less than negative 2. But if x is between negative 2 and 0, it's a quadratic. You know, it's got that x squared in there. And if it's above 0, it's this function over here, which we'll talk about later. We've got this rational function going on. So it's pretty cool things. Algebraically, I don't think it's too bad. It just says this means when x is 4. If x is 4, plug it in. Where are you going to plug in 4? Well, is it less than negative 2? Nope. Is it between here? Nope. It's the bottom one. So you just pick the function. Once you have the function, it's a matter of plug and chug. Put 4 in there, and then all you got to do is reduce. You get 2, 4 minus 1 is 3, 2/3. There's your answer. Awesome. Where does negative 6 go? Negative 6 is what? Less than negative 2. So if x is that, you plug it in the top one. So you just plug and chug. Replace x with negative 6. And then that's minus 8 plus 2. And then it's a matter of simplifying. You get negative 12. You get the absolute value of negative 20, which the absolute value is positive. So it's 22. Excellent. Where does negative 1 go? Negative 1 actually is going to fall into the middle one. So plug it in there. And then negative 2, which one? It's less than, or I'm sorry, greater than this. It's less than or equal to. So this actually goes in the top. Make sure it goes in the one that has the bar on it. So that negative 2 would actually go into the top one like this. The absolute value function there on top. So plug and chug. If you want to practice out, you're good to go. How about if I give you pictures of this? So if I give you a picture, can you do the same thing? Yeah, I don't know what the f of x is. I don't know what this part is. It looks like an absolute value function. It looks like a line and then a quadratic or a parabola. But I don't care. This is saying when x is 2, what's y? What is the f of 2? Plug in 2, what do you get? You get 0. Plug in negative 1, what comes out? Not this one. That's this open circle. You want the closed one, so negative 4 comes out. How about the f of 0? When x is 0, y is negative 3. And when x is 1, which one? It's the solid dot, negative 1. So if I have a picture, boom, it's even easier in plug and chug. You just look at it. I love it. Here's where it gets tricky. Is you got to make your own. So I'm going to do the top one in green. I'm going to do the bottom one in purple. So I have 2 different functions. So I just graph them. So what do? This starts at negative 2, and it goes up 2 over 3. Up 1, 2, over 1, 2, 3. Here it is, and I'll go backwards the same thing. So keep these points going. Fill in all these points. You know, here's my line. Up 2 over 3, up 2 over 3. But do I need all that? No. In fact, I don't want. In fact, if you want to draw it, you can draw it. But I don't need all of that because I have this limited domain. That would be if it's a normal function. This says only when it's less than or equal to 0, so I don't want any of this positive junk. I don't want anything after that. And then just make sure I'm good. Is this an open or closed circle? It's inclusive, so this is a big, fat, solid dot. It can be there. Now I go to my other one, which I said I think I do purple. So how do I graph this? Well, you start at 6. 1, 2, 3, 4, 5, 6, right here. And I'm going to go down 1 over 1. So it looks something like this. If you wanted to continue it both ways, you could, but I know I don't need anything less than 0, but you could continue that way. I draw this in there. The key is, what do I got here, though? Is it open or closed circle? It is open. To be a function, it can't be defined in 2 places there. It's everything greater than 0. So that open dot lets me know that it's the first thing past 0.1, anything like that. Awesome, piecewise function. That's it. That's the whole chapter. Man, do the review. Make sure you got that, and you'll be good to go on the test. Excellent. Good luck. Peace out.